Okay, this Friday is still from week 8, in which we took the midterm. Students from Wednesday up through Friday needed to take the midterm. Alright, so us really here then is week 9, the week after midterm. And so it is days 24, 25, and 26. So let's go through those. Introduction to Computer and Information Systems, Monday. Cyber Defense is always Wednesdays at 10 a.m. If you're curious, if you can't make the meetings, you can still get involved. And we're actually changing the name of the club. So, on Monday, we talked a little bit about gaming. We talked about learning, how much time we spent, how good it is for our health, producing jobs, how it affects society and social interactions. And there were plus and minuses both ways. Most people seem to agree health issues, it's making it worse. Okay? But otherwise there's arguments in terms of good and plus of gaming. Talked a little bit about YouTube, Content ID, how YouTube makes money, and then the ad apocalypse that happened last March. I think March of 2017, so it's been a while ago, but anyway, issues with YouTube putting ads up to matching the content or not. We are now working on websites. We have our own website, we'll talk a little bit, and then this whole next unit is talking about moving data. What's the first step in terms of what we need to understand? So let's take a look at this. I'm going to draw a line here. In networks, we have what you'll hear me call an edge. Here we have end devices trying to get into the network. Right here, we want to access networks. So one way we can do it, we can be connected to a switch, connect via wire. We can be connected to an access point, wireless. And another type of wireless we can connect to would be 4G or 5G. These are the most common ways we connect into a network. Okay? Here's you're using, let's say, your phone on your data plan, or you might use your phone and connect to a Wi-Fi either here on campus, at home, or at the coffee shop. Here we're talking about a connected wire connected to your PC or your laptop that then connects into these devices. These devices, in here we have type of routing device, switching device, access point, firewall. These are all intermediate devices. They're going to take our signal, which we're going to talk more about here in a little bit, and move it to our destination and then bring it back and get it to the right device. Okay. So the examples we're going to use are using the World Wide Web. Okay. It's one of the easiest ways to do it. We use Hypertext Transfer Protocol and HTML coding to send something to a website, and then it sends it back. And how does the addressing work for that? All right. How we pay for our access? Well, one way is bandwidth, how many bits per second we get to send, or it's a data rate, and that would be how many bytes we get to send and charge based on how much we're sending through. This would be how big a pipe we have. just if you're curious, you don't know, this stands for the Internet of Things. All of these devices, whether it's your thermostat, your refrigerator, all these different devices that are end devices that want to connect into the network in order to supply some kind of services for us. To a little bit bigger picture. Okay, so then what we looked at was this idea of a path to a network. So we have a server here on campus in the room that you can use when you're in the room. You can use this IP address to access that server, and you can access a web page on there by your ID, your login ID for that particular machine. Now typically we have a domain. Here we just have an IP address. We're going to talk more about domain names later on. This is referred to as a private IP address. It's only valid here within our LAN, okay? Within our LAN here at NAG. Now that private address is matched up with a public address that can be used via the internet. They're matched up. So if you're out in the internet and you use this address and point to your username on that system, it'll take you to your little website. Okay? Or you can practice with this one, also take to a website we're using in class. Now, sending information to and from those websites, we follow some particular protocol, some particular rule for communications. It's rules we follow for communications, and they have to be very exact in order for computers to be able to manage those. Okay, this is still week number 9, and this would represent day 25, Wednesday, 10/24/18. I left my phone on because I was expecting a phone call. Again, we reviewed the Internet of Things, all these things that connect into networks. So, BCA-101, first thing we had to do was a survey, then we did network addressing, and did a little bit of web work, and got started on assignment 4, at least looking at it and talking about it. Due next week sometime. So if we take a look here, a lot of information on this page. Let me get started. The devices, here, the devices that connect in, okay? Devices that connect in all have a physical address, okay? Sometimes that's referred to as a hardware address. But it's right in the device. It's in the device, it stays in the device, and it stays the same. Now, what's a little different is sometimes referred to then as a logical address, which is an IP address. You saw some IP addresses earlier to access the servers. This address can change depending on where your device is. So if you're using your device at home, you would get a logical address for that network at home if you're using connected to the Wi-Fi, if you're not using your 4G or 5G coming up. Or if you're on the campus, you might get a different logical address. Okay? It's like the PCs in the labs, when they power on, they get an IP address. They get a logical address based on the network they're on. Okay? Which could vary from time to time when they connect in. We typically use a concept called DHCP to get those addresses, dynamic host. Okay? So, logical address, physical address. You need an IP address to access things on the web. Typically we use some domain name, but that domain name is tied back to an IP address. Domain name services is a way to tie those two together. So you can type the domain name, michaeldirksen.com, and it's going to tie it to an IP address that gets to the correct web location. Alright, a couple other things here. So we're talking about connecting. Another way to connect would be wirelessly. Okay, so your laptop could connect with a wire to the device. PC is connected to the device. Or it could connect wirelessly to a access point based on the SSID name. Now, some SSIDs are advertised and some are not. More on that later. So we could connect to an access point, which goes through a switch, which then connects into the main campus. And then if you connected there, you would get an IP address from the main campus. Which are a little different than the IP addresses you'll get from our area if you were connecting in our area, the academic IT. Same thing over here. The dorms, they connect in to the main campus using Wi-Fi. Typically, not everywhere, but most places. So what happens is, we have a PC here. If we can follow the traffic, let's just use, we use red today. PC sends information through that's going to go out to the internet, and then it's going to come back through here. When it gets to the switch is going to send it to the correct PC based on the physical address. The IP address is going to move it through the internet, and actually the IP address is going to make it move here instead of here. Instead of the main campus, the IP address, this device knows those IP addresses go this way. It's like certain zip codes go to this town and certain zip codes go to this town. You just look at it and see which network it belongs on. One other concept here I will mention. When our private addresses, which we talk more about later on, come through the firewall, they get converted to a public IP that works out on the internet. And when they come back, they get converted back to the private address internally. That happens at your house too. We did a little work here then on the computers. We talked about intermediate devices. So these are intermediate devices, and then this router at home counts like a switch, a router, an access point. It does all those things. I have a PC connected directly into the wired, and then we have a couple laptops, a couple phones, an iPad, a TV. They're all connecting using Wi-Fi. This protocol is a little different than connecting with the wire, which would be Ethernet, or a form of Ethernet. And then we can connect into the internet here through our ISP. Our ISP actually gives us, for right here, a public IP to use on the internet. More on that later. We also talked about here of going to a website, which there's a web server sitting there, and where we're storing michaeldirksen.com. you can look up and see who the internet service provider is by taking the IP address for this domain name right here. You can look up the IP address using name service lookup Dell.com. This is at a command prompt that we opened on the computers. And then eventually you can go to Aaron.net. That doesn't have to be a capital A. It can also just be ARIN.net. And there you can search and find who's the ISP for that public address, because they're all identified in the whole world, everywhere. We also did ipconfig/all, and what this does on our PCs is it gives us the information of our logical address, our physical address, default gateway, DNS, some key things that are configured in there that we'll continue to talk about in studying networks. Last slide. So I know I'm getting anxious here probably. So, in looking at our diagram as a whole, we can be, let's say, on a laptop, and we can type in an address for, let's say, michaeldirksen.com. DNS converts that address to an IP, and then we use that IP to go out. So these routing devices will look, it'll see that IP does not belong to the main campus, doesn't belong this way, so it sends it in the internet. It goes through, the packets get switched through the internet, through different devices, and eventually ends up at my ISP. I'm going to repeat that again. They end up at my ISP. Then my ISP knows where to send it in terms of where my website is. The web server takes the HTML, and I'll use a different color going back, takes the HTML, sends it in here, and it, the internet, moves it to this ISP. This ISP knows it belongs to NIAC, it comes in here, this routing device knows it came this way, not this way because of the IP address. Goes down here, gets converted from a public to a private address. This router sends it to this switch, and it puts with it the right MAC address, so then it goes to the right device on the switch based on the physical address. So, in this big picture, we have here in the internet all these interconnected devices and routers that look at the IP addresses and can find the best path to take to get where the information, or data, I should say, needs to go based on where these ISPs are. And there's a lot of them. Okay? And that's how we connect in. Then when the ISP gets it, like Mediacom, it knows that address goes to my house, as an example. It can send it to my house. When it comes to my house, my routing device, network address translation, converts it back to the private address, and then it looks at the MAC address, and it knows which device to go to. Maybe my laptop. Okay. Well, that's it for today. We'll continue to talk about IP addressing all the way until the end of the course.